Welcome. In this video, I'm going to demonstrate how to graph a curve of a vector valued function. More importantly, we're going to try to figure out what this actually looks like and what it's called. It's a special type of curve. So let's start by drawing our three-dimensional axes. All right, here we have a three-dimensional axis. And this first part that is here should look familiar. This is a circle with a radius of 4 in the xy plane. Now, unlike our previous example, the z value is not fixed, it's changing. That means we're moving up vertically as z changes, as t changes, excuse me, because t is just going to equal the z value in this case. So we don't want to just draw this circle in the plane and then just keep drawing circles. They need to be connected. These would be discontinuous. So what this shape actually looks like is called a helix. So it's going to curve around the z-axis and look like that. And that is what our helix is going to look like. 3D Grapher, that is a separate tab within this guided lecture in Canvas. For those of you not in my class, you can see this in the description of the video, the link to this grapher. Now for x, you're going to want to type in 4 cosine t. For y, do the same and type in 4 sine t. Well, not exactly the same, but we're typing in the functions that give our x and y coordinates. The z coordinate is given just by t. And then you can move the slider around and you'll notice that this traces our curve. And you can start seeing the helix form. And if you zoom out, let's go ahead and zoom out. Let's have it trace everything it can trace. The end of where that vector u is traces our curve, our helix. And then you can see the whole helix graph. And I can change these values to say negative 50 to, negative 50 to positive 50. And the curve just keeps going. And this way, when you rotate around, you change your zoom, the curve is still there. So all the vector does, it shows you for that current t value. There it is. So for this current t value, that we rotate around so we just see 1 point. There we go. So when t equals negative 5.5, our vector is pointing in this direction. Here's its tip, and this point will make up this part, or the 1 point, in our helix. And we can keep going, and it'll just trace our curve along, leaving a trail of the points where our vector ended. And you can certainly look around from different perspectives. And here we have it in our standard XY plane. And it is indeed a circle of radius 4. Oopsies. That did not change the way I wanted it to change. Excuse me. Let's see if I can zoom out and fix that perspective a bit better. There we are. There we are. And it is a circle of radius 4. I hope you found this video helpful.